Hello students, good morning. In this video, I am going to explain the alkynes physical and chemical properties. Okay, so this is the continuation of the last video. Okay, from this video onwards, I am going to add some important previous year NEET and JEE questions related to the reactions. Okay. So at each reactions, what are the previous year questions asked and what are the expected questions, those also we'll discuss. So from this video onwards, related to the reactions, all types of models, okay, related to the previous year NEET and JEE questions will be covered. Physical properties of alkynes, okay, similar to the alkenes and alkanes. Okay, here also the alkanes also first three members are gases. Acetylene, okay, methyl means ethyl. Next, propyne, butane. These three are gases. Okay, these three are gases. Okay. Next, from C5 onwards, next 8 members means up to 13. These are liquids. These are liquids. Remaining alkynes are solids. Remaining alkynes are solids. Okay. Next, these alkynes are insoluble. Okay, these alkynes are insoluble in polar solvents like H2O. Okay, and they are completely soluble. Okay, completely soluble in organic solvents. In organic solvents. Organic solvents means it may be benzene, ether, acetone, okay, diethyl ether, all. Okay, so all the organic compounds which are in liquid state can act as solvents. Okay. Next, alkynes are weakly polar in nature. Alkynes are weakly polar. Sorry, alkynes are weakly polar in nature. Okay, alkynes are weakly polar in nature. Okay. Next, alkynes, in alkynes, density. Okay, density directly proportional to mass. Means the density increases with increase of number of carbons. Okay, number of carbons. Okay, so density increases with increase of number of carbons, and it will reach to a maximum value. Okay, so max value 0.8, and water density H2O density is 1 gram per ml. Okay, so all the hydrocarbons, okay, all the hydrocarbons, they have less density than water, so they will float on the surface of the water. Okay, these alkynes are colorless and odorless compounds. Alkynes are colorless and odorless compounds except acetylene. Okay, so it will give vinegar smell. Okay, so except acetylene, remaining all are colorless and odorless compounds. Okay, so these are the physical properties of the alkynes. Okay, and next one now, chemical properties. Okay, chemical properties. In this chemical properties, first one we have to discuss acidic nature. Okay, acidic nature of alkynes. Okay, acidic nature of alkynes. Here, acidic nature means alkynes are not strong acids. Okay, these are very weak acids. Okay, these are weak acids than water also. Okay. In alkynes, the hydrogen which is attached to the triple bonded carbon is acidic hydrogen. Okay, the hydrogen which is attached to the triple bonded carbon is acidic hydrogen. Okay, so why these hydrogens are acidic? Because this triple bonded carbon is more electronegative. Okay, so if you see the electronegativity order of triple bonded carbons, Okay, if you see the hydrocarbons electronegativity order, if you see the electronegativity of the hydrocarbons, triple bonded carbons are more electronegative than double bonded carbon than single bonded carbon. So to the more electronegative atom attached, hydrogen is the more acidic. Okay, so if you see the hydrocarbons acidic character, alkyne acidic character is more than alkene than alkane. Okay, so how we can tell this is a more acidic? Here, based on the percentage of S character. Okay, based on the percentage of S character, we can tell the alternativity. So percentage of S character more means more alternativity. Here, sp hybridization. So percentage of S character 50%. Here, sp2 hybridization. Double bond means sp2. Triple bond means sp. So here, 33.3%. Here, sp3 means 25%. So more is the percentage of S character, more is the electronegativity. Okay. So more is the percentage of S character, more is the electronegativity. So to that more electronegative species attached hydrogen is a more acidic hydrogen. Okay. So in this way, alkynes containing acidic hydrogen are more acidic than alkenes than alkanes. Acidic order of some examples. Phenol is more acidic than H2O. Okay, H2O is more acidic than alcohol. Okay, alcohols are more acidic than alkynes. Okay, next NH3. Okay, so NH3 after alkene. Okay, later alkane. Okay, so this is the weak acids acidic order. Okay, so phenol is more acidic than water, later alcohol, later alkyne, later NH3, later alkane, later alkane. Okay, so this is the introduction to the alkynes. Okay, next, what are the reactions to the acidic character? Okay, so because of which reactions we can confirm the acidic nature of alkynes, that we will discuss. Reactions to acidic nature. Reaction with the sodium amide. Okay, so styrene means CH triple bond CH. On reaction with the sodium. Okay, or sodomide means NaNH2. Okay, what is happening here? Generally, acids when they react with the metals, okay, what is happening? They will liberate H2 gas. Here also this hydrogen is replaced by Na. So CH triple bond C Na, and that hydrogen is removed in the form of H2. Okay, hydrogen is removed in the form of H2. Here also this hydrogen is replaced by Na, and this hydrogen is added to NH2. It will be removed as NH3. Okay, remaining here also hydrogen is replaced by Na. So same compound only will get CH triple bond C Na. Okay, here this compound name is sodium acetylide. Sodium acetylide or sodium alkynide. Okay, this is alkyne. So alkynes containing acidic hydrogen are reaction with the sodium or sodomide. What they will give sodium alkynates, they will give. Okay, and with Na means they will give liberator. With Na means they will liberate H2 gas. With NaNH2 means they will liberate NH3 gas. Okay, if you take the 2 moles of sodium, okay, CH triple bond CH, 2 moles of sodium or 2 equivalents of sodium. What is happening here? 2 acidic hydrogens are there now. So 2 acidic hydrogens are replaced by 2 sodium atoms. Okay, then what will get? H2 gas will get. If you take NaNH2 also, 2 moles of NaNH2 if you take also, here also what is happening? It is happening, this alkyne reaction with NaNH2, here also same compound. Okay, 2 hydrogens are replaced by 2 sodium atoms. With the removal of NH3, how many moles will get? 2 moles of NH3 will get. Here this is disodium. Okay, disodium acetylide. Okay, disodium acetylide. Okay, so these disodium acetylides or sodium acetalides or sodium alkynides, they are used in the preparation of higher alkynes. How these will be used in the preparation of higher alkynes? Suppose CH3, okay, CH3, C triple bond CH, or reaction with an alkyl halide CH3Cl for suppose. Okay, here this is sodium esteride. So sodium propionide here. 3 carbons containing alkyl hydrogen. So sodium propionide and reaction with methyl chloride. What is happening? This Na and Cl will be removed in the form of NaCl. Then this CH3 will be added to this triple bond carbon. Then CH3 C triple bond C CH3 will get. Okay, so 2 butane will get. So if you take propine, sodium propionide and react with methyl chloride, you will get 2 butane. If you take the ethyl chloride, for suppose ethyl chloride means sometimes they will use C2H5Cl. Okay, this we can write like this also, CH3 CH2Cl. Okay, so in this case what is happening here also, this Na and this Cl will be removed in the form of NaCl. Later this ethyl group you have to add to the triple bond carbon. Here you have to break the bond, carbon halogen bond you have to break. Where you are breaking bond, okay, that carbon you have to add to the triple bonded carbon. Then what will get? CH3C triple bond C. Here to this part, up to here I written. Okay, later to this part, this CH2 CH3 you have to add. CH2 CH3 you have to add. Then what is the name of 1, 2, 3, 4, 5? So 2 pentyne. Pentyne will get. In this way we can prepare the higher alkyne. If suppose if you take the disodium esteride, okay, if you take the disodium esteride Na C triple bond C Na, this are reaction with the suppose ethyl chloride CH3 or ethyl bromide, not only chlorine, you can take bromide also. So if you take here 1 mole, if you take one side only will be replaced. If they didn't give a number of moles, okay, you have to consider this 2. Okay, here 2 sodium atoms are there. So 2 sides, these 2 Na atoms are replaced. These 2 Na atoms are replaced by these alkyl groups. Okay, so these 2 Na and these 2 Br atoms will be removed as 2 moles of NaBr. Okay, later to the triple bonded carbon. So this side by replacing Na, one ethyl group will be added. So CH3 CH2. This side also by replacing the Na, one more ethyl group will be added. So CH2 CH3. Okay, so what is the name here? 1, 2, 3, 4, 5, 6. Okay, so 3 hexane. Okay, 6 carbons and alkyne. So hexane at third position triple bond. So 3 hexane. So in this way we can get the higher alkynes by using the sodium alkymides. Okay. Next one, reaction with the Grignard reagent. Okay, so these also indicate the acidic nature of alkynes. So if alkynes containing acidic hydrogen, suppose CH3 C triple bond CH. This is propine. Okay, so propine are reaction with the CH3 MgBr. Okay, RMgX is called Grignard reagent. Okay, so CH3 R means alkyl group, Mg, X means halogen. Okay, so CH3 MgBr. These are reaction with propine, means here acidic hydrogen is there. Okay, what is happening here? Here only acidic hydrogen will add to this alkyl group. Only acidic hydrogen will add to the alkyl group. Okay, later the remaining part by breaking this bond. This remaining part will add to the Mg. Then what is happening? Here CH3, which alkyl group is there? To that one extra hydrogen you have to add. Okay, so CH4 will come. Remaining here Mg, and this alkynide also will be added now. So C triple bond C CH3. This will be added. And what is one more halogen? Br. This Br as it is MgBr. To this alkynide. Here H plus means this is minus C minus. This part will be added to the Mg. Then we will get this compound. Okay. So here, if you take any acidic hydrogen containing compound also, for suppose CH3, CH2. Okay, CH. Okay, this is 1 butyne. Here, if you take any other Grignard reagent also, for suppose if I take the isopropyl isopropyl Grignard reagent, MgCl. Here also what you have to do? Here also this is the acidic hydrogen, this is acidic hydrogen. Okay, so from this alkyl group of magnesium bond you have to break. This hydrogen you have to add to this carbon. Okay, this hydrogen you have to add to this carbon. The remaining part you have to add to the Mg. So what will get? Here CH3, CH. So to this one more H is added means CH2. So CH3, CH2, CH3 you will get. Okay. The remaining part Mg. This alkynide. Okay. So Mg, Cl, alkynide water, butyride. Okay. So C triple bond C, CH2, CH3. In this way. Suppose if you take the first compound styrene. Okay, CH triple bond CH. This are reaction with CH3 CH2 MgBr. What is happening here? From this also one hydrogen you have to add to this carbon by breaking this bond. By breaking this bond, this hydrogen acidic hydrogen you have to add here. Remaining part. This remaining part you have to add to the Mg. Then what will get? Here initially what alkyl group is the ethyl group. The ethyl group one more hydrogen is added means what will get? Ethane will get. Mg, Cl, and what is the alkynide? Ethanide. So C triple bond CH. So in this way this compound will get. Okay. Right. Next test. Test for alkynes. Test for alkynes. Next, test for alkynes containing acidic hydrogen. Test for alkynes containing acidic hydrogen. First suppose if you take this alkyne, styrene or ethane and react with Tollens reagent. Tollens reagent means ammonical silver nitrate solution, AgNO3. Okay. Ammonical silver nitrate solution. What is happening? These hydrogens are replaced by Ag. Okay. So CH, C triple bond. So CH triple bond C, Ag will get. CH triple bond C, Ag will get. This is a white PPT. Okay. So in this way, silver acetylide or silver alkynide is forming. Okay. So remaining side products no need. So what color precipitate you get by reacting with what? That is only important. This is called Tollens reagent. Sometimes they will give like this Ag NH3 twice the complex form plus like this also they will give. Okay. So this they given means that is Tollens reagent. Acidic hydrogen containing compound they will give white precipitate with the Tollens reagent. Similarly, one more reagent is the Alkynes reagent. With that also acetylene reaction with Cu2Cl2 in the presence of NH4OH. Okay. So cuprous chloride solution. Here also what is happening? Here also this is called a Alkynes reagent. Okay, so this is called Alkynes reagent. Here also what is happening? Acidic hydrogen is replaced by Cu. Acidic hydrogen is replaced by Cu. So CH triple bond C, Cu. This is a red color precipitate. Okay, here white color precipitate, PPT means precipitate. Here red color precipitate you will get. Okay. Next, one more test is that. Okay, okay. Next, here very important point. Okay, alkynes containing acidic hydrogen will react with the sodium metals. Okay, will react with metals. Okay, but will not react with the alkalis like bases. So alkynes react with the NaOH. No reaction. Okay, so here these are the not that much acidic to react with this one. Okay, these are strong bases. These are strong bases, very very strong bases. These are not strong acids to react with this one. Okay, so these are very very weak acids, so they will not react with the NaOH. Okay, so only carboxylic acids and phenols. Okay, phenols containing electron withdrawing groups, so they will react with the NaOH. But alkynes do not react with the Na. Alkynes do not react with the NaOH. With Na they will react. With the NaNH2 also they will react. Okay. Next with AgNO3 also they will react. AgNO3 also they will react, and Cu2Cl2 also they will react. But they will not react with the NaOH. These are the some important model questions and the previous year, previous NEET and JEE asked questions. Okay, based on the acidic nature of hydrogen, based on the acidic nature of alkyne. First question: ascending acidic carbon of the following hydrogen atoms is. Here CH triple bond CH. This hydrogen CH2 double bond CH2. It is also this hydrogen. Next here CH3 3 times CH. CH3 CH2 H. So in all these cases, underlined hydrogen atom acidic character you have to write in the order. Okay, so here this is alkyne, this is alkene, this is alkane. So previously as I told, alkynes are more acidic than alkanes. So first one is more acidic than the second one. Next second also more acidic than the 3 and 4. Why? Because these two are alkanes and this is alkene. Next in these two, here these are plus I groups. Okay, these are plus I groups. Here how many plus I groups? 3 plus I groups. CH3, CH3, CH3. Here only one CH3. Okay, generally plus I group will decrease the acidic character. Here more plus I groups, it will decrease more. So which is more acidic? Fourth one more acidic. Here due to the presence of more plus I groups, so acidic character decreasing more. Okay, than this one. So that's why 4 is more acidic. Later 3. This is the acidic carbon of the given compounds. Okay. Next second question. Metallic sodium does not react with metallic sodium does not react with metallic sodium will react with the weak acids and it will liberate which one? H2 gas. Here 2-butane. 2-butane means CH3 C triple bond CH3. Here any acidic hydrogen is there? The 2-butane no acidic hydrogen. Acidic hydrogen means hydrogen which is attached to the triple bonded carbon atom. So here no acidic hydrogen. So this will not react with the metallic sodium. Tertiary butyl alcohol, weak acid, so it will react. Next NH3. Here also this is also weak acid. It will react. Okay, ethane. Here tertiary butyl alcohol means here hydrogen attached to electronegative atom. So this is acidic hydrogen here also in NH3 ammonia. Here also hydrogen attached to the electronegative atom. So here also it will react. Next in the ethane, CH triple bond CH. Here also hydrogen attached to electronegative atom. So this also will react. So these three compounds will react. This one will not react due to the absence of acidic hydrogen. Okay. Next 3-octane is obtained by reacting with 3-octane is obtained by reacting which bromoalkane with which alkyne. Okay. See here, first you will write the 3-octane structure. 3-octane means what will get? Okay, so oct means 8 carbons, so 8 carbons written. 5, 6, 7, 8. 8 carbons written. 1, 2, 3, 4, 5, 6, 7, 8. The third portion you have to write a triple bond. This is 3-octane. Okay, this is 3-octane. 3-octane is obtained by reacting with one a bromoalkane and the alkyne means here after triple bond you have to break. To this you have to add sodium. So sodium, this alkynide will react with this bromide. So here this side you have to add Na, this side you have to add which halogen Br. So with which bromoalkane is reacting with which alkyne means here this which one? This alkynide. This alkynide means CH3, CH2, 4 carbons containing alkynide means Okay, CH3, CH2, C triple bond, CNA. So sodium butanide. And what is the other compound which are bromoalkane? Remaining alkyl group 4 carbons. So butyl means CH3, CH2, CH3, CH2, 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 Br. 4 carbons containing bromoalkane you have to write. Okay, so by reacting these two compounds, we'll get a 3-alkyne. Okay, right. Next, fourth one. This propane react with the Grignard reagent produces which gas? Okay, so any acidic hydrogen containing alkyne also are reacting with the Grignard reagent. In the Grignard reagent, what alkyl group is there? To that one hydrogen you have to add. This hydrogen only you have to add. This hydrogen only is added to this one means it will CH3 will become CH4. CH4 means methane. So answer is methane. Okay. Next to propane and propene distinguished by which one? Propane means alkyne, propene means alkene. Okay. So generally alkynes containing acidic hydrogen is more. Alkynes containing acidic hydrogen can be detected by with the Torrance reagent with the metals. Okay, with Torrance reagent, Felix reagent with metals. Here with concentrated H2SO4, it will react. Both will react with PR2 in presence of CCl4 also both will react. With the dilute KMnO4 also both will react. With the AgNO3 only alkyne with the acidic hydrogen will react. So alkene with the acidic hydrogen will not react. Okay, so alkene with acidic hydrogen will react with AgNO3, but alkenes do not react. So answer is AgNO3. Next, here this sodium propionide, this one sodium propionide are reacted with isopropyl bromide. Here what higher alkyne will come? Comment that. Maximum you will get 99%. If you listen to the full video, you will get the answer. Who are getting, you can tell your answer in comment box. Okay, who can answer that? You can write your answer in the comment box. Next, 1-butene and 2-butene are distinguished by. Okay, 1-butene and 2-butene are distinguished by which one? 1-butene means terminal alkyne, or 2-butene means non-terminal alkyne. Okay, so 1-butene means CH3, CH2, C triple bond, CH. Here 2-butene means CH3, C triple bond, C, CH3. Here any acidic hydrogen is there? No. Here acidic hydrogen is there. No? So acidic hydrogen will react with which one? Ammonical cuprous chloride, which is acting as Ferenczi reagent, and it will give red precipitate with this one. Here both 1-butene and 2-butene both will react with all these three. Okay, but 1-butene only will react with the ammonical cuprous chloride. Okay, and it will give red precipitate. Okay. Next, which conjugate base is strong? Okay, which conjugate base is strong? So, in all these bases, which is the strong base? Okay, which is the strong base they asked. Okay, so already I given the acidic order of some compounds. Okay, so what I given acidic order here? Phenol more acidic than H2O, than alcohol, then alkyne, then NH3, then alkyl. Okay, so here these are the conjugate bases of these compounds. So if the acid is a weak acid, its conjugate base will be strong base. So here which is weak acid? NH3 is weak acid, so its conjugate base NH2 minus is a strong base. So third option is the correct answer.